Hello, and welcome to this North Green video about SQL injection. In this video, we're going to look at SQL injection, which is one of the most well-known vulnerabilities in web security. We're going to walk through a practical demonstration explaining how and why we can craft malicious SQL payloads that can be used to extract data. Now, SQL injection happens when a website takes user input and includes it into a database query without properly sanitizing it. This allows us as attackers to manipulate the query and try to extract, potentially modify, or even delete data from the database. Now, the website we're going to look at today has a search functionality, and when looking for SQL injection, you are looking for any kind of functionality within a website that looks like it might be talking to a database. Search functions are really good places to have a look at SQL injection vulnerabilities. Now, in our web page here, we've got our query for debugging string at the bottom to help us understand what is the request that is actually going to the database when we are creating it. So let's have a look at how this works. If I first of all just simply type in the letter A into our search box, what we can see is I get a couple of results come back. So this is because what's happened is the website has sent a query to the database saying, select the page and name from a table called search, where the name column is like, and then we've got our user input here. So what's happening is we have a percentage wildcard character, our input, the A, and a percentage wildcard character afterwards. This means that we're getting a very normal response, and that the website will return back anything that has the letter A in it, which is why we have about and contact us. So now we know the functionality works. That's not particularly interesting as attackers. Now we want to see, can we take control of this query? Can we make it do what we want it to do? So first things first, what we're going to try is putting in A again. We know that's a valid query. I'm going to try putting in a single quote. And we can see we get a different output here. We get nothing coming back. Now what's happened is that that single quote has prematurely closed the string where we're putting our data. If I just zoom in to our query here, we can see that what's happened is we have closed off the parameter that as users we are talking to, and the database is going to have an error here because it has opened the parameter that we're able to use. We have closed the parameter that we are able to use, and then it still has this third quotation mark here. So this is going to break because the database isn't sure what's going on. So what I'm going to try and do is see if I can just get a generic search that works, but that I'm able to control. So because we know what this search looks like down here, I'm going to use that to my advantage. And I'm just going to search for A. I'm going to use that wildcard character as well. I'm going to close the parameter. And to make sure that the database doesn't error, what I'm going to use is this double dash. When I search for this now, we can see that I get my legitimate results again. What's going on here is that we have been able to turn around and say, search for anything with an A in it, and this double dash here tells the database to ignore everything after it. This is a commenting character. We are commenting out the rest of the query. It means that the rest of the query is completely ignored. That's why that last percent quote is no longer causing an error. So you may think, great, we've got the same output as we had originally. That's not useful to us. But what we know from this is that we can control this query. So whenever we're trying to extract data from a database, what we would ideally like to do, and what is one of the most common things to try and do, is make a union select query. What this essentially does is it adds a second query to the database. So it appends an additional query going to the database. And if we can get that to work, we can start to extract data from the database. Now, what I'm going to do is I'm just going to build on the query that I've created. I know a percent is a legitimate output. So I know that as long as I get this about and contact us, I know my query has gone to the database. You don't necessarily have to do this. You could just use that quotation mark and close off the query. For me, I just like the peace of mind knowing that it's definitely gone and executed the legitimate command. So what I'm going to do is add union select 1. Now what this is saying is go and get the results for A. Also put the number 1 in the first column that is part of my query. So my union select 1 is saying also go and get me the number 1. Now the reason this hasn't worked is because when we turn around and use union select, we need to have the same number of columns on both sides of the union. So we can see here, we have a select for page and name. That is 2 columns worth of data. Doesn't matter that visually we don't see 2 pieces of information. The query to the database is requesting information about 2 columns worth of data. We have turned around and said, also, I'm going to give you another select statement, and I want you to go get me the integer 1. This has not worked because I'm only asking for 1 column worth of data. If I simply change my query to say union select 1, 2, then I get the number 2 at the end here. Now this means that I'm able to understand that I can request data to come back from the database. While that may not seem remotely important at the minute, this is again something that we can build on top of. So now we know that we can talk directly to the database. One of the most important things to be able to do is identify what kind of database are we talking to. This is because different databases require different syntax. So by being able to identify what kind of database we're talking to, we're able to then turn around and make sure we're using the right syntax and the right commands. So I'm just going to create my next payload to say run my legitimate command, close the parameter, union select that, also go and get me some data. And I need to request 2 columns worth of information. I'm going to request 1, at version. Okay. What this at version request is doing is it's turning around and saying, if you understand the command at version, which databases like MySQL and MS SQL do, give me the version of database you are using. And we can see we get an output here. Now I've put union select 1, at version, because quite clearly it is the second column worth of data that is being presented visually on the screen. So it's always going to be that second column that I'm going to put the command that I'm trying to execute, that I'm going to try and put the data that I'm trying to extract into. So now I know that this is using a MySQL or MS SQL database, because any other kind of database would error when we asked for the @@ version. It wouldn't understand what that command meant. If @@ version had errored, I might try something like SQLite version, or I would try the version command for other databases. But now I know that I'm talking to what is likely to be a MySQL database because it's running on a Ubuntu server. If it was an MS SQL database, I would expect it to be running on a Windows server. So I'm going to assume this is MySQL. Now that helps me because there are standard commands that I can run to be able to get information about the database. Okay? And what I want to do is I want to be able to turn around and say, go and get me information about the tables that are part of this database. So I'm going to run a query for A, close off that user input. I'm then going to do my union select. I need to request 2 pieces of information. So 1, and then this is the information that's actually going to be shown to me. Now for MySQL, I can search for table name, and this is going to be from the information schema. Now the information schema is essentially holding data about the database. You can think of it almost like a phone book or a glossary or something like that. We can query the information schema to say, give me some information. So if I scroll down, you can see that what I've got is a lot of information about table names. Now, a lot of this is about the database as a whole, but if I keep scrolling down, I can try and see if there is anything that jumps out at me. And for me, I like the idea of there being a user or a users table. Now, I might not be sure which one to talk to yet. User is likely going to be the table holding the MySQL database users. Users will hopefully be the table about the website. I'm going to make that assumption based on the fact that guestbook, search, users, accounts, all would be something that this website would have created. And we can see if I scroll right down to the bottom, this is the query that I have run. Union select. So don't just run the first query, also go get me the information about table names from the information schema.tables. Now I've got a table that I'm interested in, the users table. Just going to scroll all the way back to the top so I can see my search bar. I'm going to turn around and say, here's my input. I'm going to do a union select. And this time, what I want to know is I want to know what column names are in that user's table. And I want to know that because if I know what column names are in that table, I can request information from them. So I'm going to search this time for column name from information schema. And then I'm going to use where. So I'm talking to the information schema specifically about columns. And I'm going to do where table name equals users. We can see that has successfully executed. I've still got my about and my contact us for my legitimate query, but now I've got the column names that are part of that table. You can see here down here, this is the request that was made. Go and get me the column names from the information schema.columns where the table name is users. So now I know what column names exist in that users table. I can turn around and start trying to extract potentially useful information from them. The 2 that jump out, username, password. Okay, potentially valuable information. Now I can't get both of those at the same time yet because I've only got one piece of output being displayed on the screen. So I'm going to request those individually. I'm going to run my query that says union select I need to request 2 columns worth of data, so I've got to have that one first. So I'm going to say 1, and then username, and then I've got to say where that data is coming from. So from users. We can see that I have 3 users in my table: admin, Dan, and Dan2. So now what I can also do is I can make a request for everybody's password. So I can say a %, end the parameter, union, select 1, comma, password from users. And we can see here that I get the password value for each of these users. We see our query at the bottom was a %, end the parameter. So this is our legitimate query that gives us that about and contact us output. And then I've done a union select 1 password from users. So this is going and getting me the password value from users. Now, the eagle-eyed among you may have spotted that I keep adding a space here. I just want to explain why I'm doing that. So some databases, like MySQL, require a space after the comment character so that they're recognized as a comment. Sometimes without that space, they will just ignore the comment. They'll throw out an error. So that space is just to make sure that everything's working. If I show you that command again without the space, a % union, let me move the mouse out of the way, select 1 password from users. And this time I'm not going to do a space. We can see we don't get anything back. The database has errored. It's not giving me a visual error to work with, but that lack of space between my commenting character and the % is causing MySQL to error. So that's why I keep adding that space to the end. Okay, so we've been able to get usernames, we've been able to get passwords, we've got to get them separately, and we've got to match those up ourselves. And that's not particularly ideal. We might want to just be able to get everything all at once in one query to be able to make life much, much easier for us. So what we can do with databases like MySQL is we can use concatenation. So we can concatenate different parameters together. So to do that, I can do a %, my legitimate query, and then I can do union select 1. So I've always got to have 2 things I'm asking for. So it's always that 1 and then something that I actually want. And this time I'm going to type concat. So I'm going to concatenate multiple columns together. Now there was the column ID. I want that. I then want to have some kind of delimiter to kind of show me this is where ID ends. This is where the next one starts. So I'm going to use a hex command to say, put in a colon. Then I'm going to ask for usernames. Then I want another colon. And then I'm going to ask for the passwords that are in there. And I've got to say, what table am I getting this from? I'm getting it from the users table. And I'm doing that comment out at the end there. So you can see this time, if we look at the query down here, I've turned around and said, get a concatenation of ID, username, and password. And I've got my delimiter of a colon between each one to help me understand when each parameter ends. Now for this, it's relatively obvious when they end anyway, but this could be helpful when you're going from username to password or first name to surname, potentially. But this is a way that we can concatenate data together from multiple columns and request it as though it's only one piece of data. And finally, what I want to show you for SQL injection, depending on what database you are talking to, is really going to depend how effective SQL injection can be. MySQL is particularly interesting when you find injection because it also has functionality to allow you to read files on the server. So you've got that potential to go beyond the database and have a look at the server. And we can do that by using the load file function. So the last payload I'm going to show you is a legitimate query, union select one, and then load file. And I'm just going to look for etc password. And we can see that what this is doing is it's gone to the server itself. I've gone and got me the etc passwd file. Now this could be used to try and load any number of files, could be used to try and help me enumerate usernames that I might try and brute force through SSH or something like that. But ultimately, this is showing that I can also go and query data from the server itself. So let's just recap what we've gone through. We started with our basic input to understand how data is being processed by the SQL query. We've been able to identify that the application was vulnerable to injection by putting in our original single quote and prematurely ending that parameter and causing an error, which was represented by no data being shown on the screen. We've then been able to use union select statements to be able to extract data from the database, ranging from table names to column names, and ultimately ending in being able to extract usernames and passwords along with even these system files. And this has meant that we've been able to completely compromise the confidentiality of any kind of data held within this database. But ultimately, we've got to understand why has this happened. The root cause is that the application is taking user input and just allowing us to insert that into the SQL query without proper validation or sanitization. This is allowing the attacker to manipulate the database by manipulating the query. Now, if you're a developer looking at this, or you're a pen tester wanting to know how can you recommend people solve this problem, we can turn around and use things like input validation and whitelisting, trying to restrict what characters people are allowed to put into things like search bars. We can use what's called prepared statements or parameterized queries. That means instead of inserting user input directly into a query, it uses placeholders and treats input as data, not as code, not as commands. And we can also try and do things like just adding in WAFs, adding in web app firewalls that can try and identify these kind of the application and filter them out before they get to the database. Thank you for watching. I hope you learned something. Please like and subscribe to the channel if this has been helpful for you, and we will be putting more videos up shortly.